Hello, good morning. So, paper one done, now on to paper two, and today I'm going to go through some, predictions, not really by me, but by some other people who've done some really great analysis of, the number of times, percentage of times that certain questions come up on these tests. And so which ones, didn't come up on paper one, so we think, or they think, could come up on paper two, and the likelihood of that. So hopefully today it will be, really useful in terms of giving you an idea of things that are likely, based on what's come up previously, to come up again. Okay, so it's not a silver bullet in terms of it will not tell you exactly, it will not just solve everything and inform you on exactly what's going to be on the test. It's not going to work that way. It's not going to be, it's not going to be as informative as it was last year with the predicted papers. Last year there was advanced information which basically allowed people or told people what was going to be on the test. That's not the case this year, and so it's basically a best guess. So that doesn't mean that things that were on paper one are not going to be on paper 2 and 3. Of course they could be. Okay, this is just looking at the probabilities, the likelihoods of what's been on there previously, and so what these people think is going to be on these next papers. So like I say, hopefully it'll be useful, and I'm going to go through some of the questions, some of the topics that are in these predictions as well, to help give you some more practice, and anything that you're not sure about that is on those predictions, you will have some idea of. And I've also put in the description the links for where these predictions are from. They're not my own, so I just want to be clear and say that. But again, they can be very useful to have and to know. Okay, so I'll give everybody a second to join and have a look at some of these questions. So these questions, these topics are on these predictions, and obviously the predictions are different for different examining boards. So different for Excel, different for AQA, obviously, because paper one was different. I've got GCSE as well, which will be useful. Haven't got OCR yet. Haven't managed to find somebody who's done the predictions for that. So I'll give us a second, and then I will put those on the screen. The number of viewers has gone down. I expect that's probably because you've all clicked on the link in the description and decided just have a go and have a look. So yeah, give us a minute or so just have a think about some of these questions. I hope as well that paper one did go well. From what I've seen, and people I've spoken to, paper one generally was good for most people, but again, that was something I saw on Twitter, the Twitter poll, so could be right, could be wrong, I don't know. Anyway, I hope it has gone well for people that are watching this back. And if this is useful, please like the video so that I know it is, and I can make sure to do these in the future as well, because this should be something that can be done as well before paper 3. So again, after paper 2 you'll know the topics that have been on paper 1, the topics that have been on paper 2, and then topics they haven't examined will most likely then be on that paper 3. Okay, right, I'll make a start and go through these questions. So rounding 9.9995 to 2 decimal places. Well, after my decimal point, go 1, 2 places, and then you can do like a line if you like. Go after that, it's a 9. So that 9 is 5 or above, so that will round this 9 up to basically a 10. Carry the 1 over, that then becomes a 10. Carry the 1 over, that will then become a 10. So this to 2 decimal places is 10.00. Now, quite often people ask, well, do you need to write the decimal places? Do you need to write those zeros? Because actually they don't change anything. And my advice and suggestion would be, well, yes, because it says the 2 decimal places here, so you need to write in your 2 decimal places, whatever they are. So, yes, you do need to write decimal places would be my recommendation. Now for the next one, 3 significant figures. Now you start counting your significant figures from the first non-zero number. So 8 would be my first significant figure, and then after that the zeros count once you've started counting. So 1, 2, 3, line in, look over, it's a 5. So that means 5 or above, you round up. That 8 is going to go up to 8, 4, 9, and that 5 goes to a 0, and then 0.0, but we don't need to write that. Okay, next question is a ratio question. So given that A to B is 3 to 4 and B to C is 5 to 2, find the ratio of A to B to C. Okay, now the common part here is this B. Okay, so what we need to do is we need to get it so that our B parts are the same. Okay, so at the minute the B is 4 for the first ratio and the B is 5 for the second ratio, so I need to find the lowest common multiple. So I will want to make that 20 because that's the smallest number that is in the 4 times table and the 5 times table. So I'm going to turn this into, or times by 5, 3 times 5 is 15, 4 times 5 is 20, and then B to C, I'm going to times that by 4, so I'm going to get 20 to 8. Now, then I can combine them because both B parts of this ratio is now 20, so A to B to C is going to be 15 to 20 to 8. Okay, so that one I times by 5, that one I times by 4. Now you've got to make sure it's in its simplest form. Now as long as I found the lowest common multiple of the common part in both ratios, you know, the B part here, as long as that's the lowest common multiple, this should be as simple as I can make it. Because, well, usually it will be, or I should say most of the time, but do make sure you check. I mean, that has only got factors of 3, 5 and 115. 5 would go into that, but 5 won't go into 8, so that's the simplest form. And then the last question here is Pythagoras. So a 4-metre ladder is placed against a vertical wall. The base of the ladder is 1.5 metres from the base of the wall. Work out how far the ladder reaches up the wall. So we've got 4 metres here, 1.5 metres at the bottom. Opposite my right angle is the hypotenuse, so I need to do 4 squared, subtract, because I'm working out shorter side, 1.5 squared, and square root it. Okay. So if I do that, 4 squared minus 1.5 squared is equal to 3.7, and it doesn't say whether it wants it to, it just says work out how far, it doesn't say we need to round it to, so I'm just going to go with 3.7 to 1 decimal place, and that would be in metres, don't forget the units. Okay, right, so the bit that, if you're watching this, you're probably interested in, and probably the most useful bit next is actually what are these predictions, if you like. Now, this is done by First Class Maths, which again is an excellent resource, and what they are uploading onto their website, which is linked, is not only these predictions, but also a predicted paper, so with video solutions. So you can use that paper and then go through and mark it using the videos. Now these, they have a lot more in terms of predictions than this. There's a whole page. Basically 5 stars means that's the most likely, 4 stars less likely, you know, going down to 1 star, which would be least likely. So these are what they believe to be the most likely things to come up on the higher AQA paper. So sequences, volume of a 3D shape, trigonometry, averages and range, proportionality, so y is proportional to x, or you could have inverse proportion, and you could have, you know, x squared, square roots and things like that in there. increase or decrease by a percentage, sequences, and then there's more down here in the 4-star section. So I would go through this and think, well, actually, do I know how to do all of this stuff? And rectilinear area is just rectangles, basically. Yeah, so I would use this as basically suggestions and things that you want to make sure you've gone through, but you also want to, practice generally everything. These are recommendations, not guarantees. Okay, so it could be the case that actually, although this is in 5-star, that actually it might not come up. Okay, it might be that some of the stuff in the 1-star, that the least likely stuff comes up, and it might be that actually some other stuff comes up. So these are only predictions and recommendations for using for some of your revision, basically. From myself, recommendations, that would be, not from First Class Maths. They're just their predictions of things that could come up. Now, foundation AQA, we've got sequences, time calculations, gradient, intercept, y equals mx plus c, so straight lines, percentage of amounts, direct proportion only, so things like best buys, recipes, units, metric units, averages from a diagram or a table, algebraic expressions, linear equations, algebraic expressions from context, and then sequences again. Okay, and then there's also less likely things. If you go onto the website, have a look there. Now here is Edexcel. So you've got standard form, sequences, again rectilinear areas, rectangles, triangles, parallelograms, trapeziums. Okay, so that, when it was referring to rectilinear areas earlier, you could have had these shapes as well. Circles and sectors, Pythagoras, speed, distance, time, trigonometry again, transformations, algebraic fractions, probability. So some overlap there in terms of things that could come up. Sequences, trigonometry. Just correct what I'm saying there. Could come up. All of these things could come up. All of the different topics could come up in terms of First Class Maths predictions, 5-star predictions. They're what they believe to be the most likely ones to come up, I should say. Now what they think is likely to come up for foundation, standard form, ratio 1 to n, transformations again, rounding numbers, probability again, area of shapes again, sharing into ratio, metric unit conversions, and time calculations. Okay, in terms of what they believe is most likely to come up. I'll keep saying that because that is what this is, and I don't want this to be confused with, oh well, if I just revise these topics then I'll be fine, because that is not necessary. It's not going to be true. There's going to be other topics on there, obviously. Now, in terms of the advanced maths and IGCSE, this doesn't really, well, it doesn't give you a levelled prediction in the same way that First Class Maths does, but that's fine. This is just given suggestions and predictions of things that will come up on paper 2, the final paper for IGCSE. So, and it also gives places to go to and to use, so circle theorems and where to practice. They've got videos on the website, and then practice. They've got links to Corbett Maths and other resources from different places. Okay. But yeah, things like circle theorems, algebraic proof, surface area of 3D shapes, quadratic simultaneous equation, differentiation, which is something which is different and only on the IGCSE, as far as I'm aware. And we've got some more things here. So completing the square, angles in polygons, bounds, bearings, and surds, things like that. Okay, so these are their predictions of what things didn't come up on the first paper, which could come up on the second paper. Okay, right, so starting to have a go and work through some of these questions. Work out the difference in minutes between 2 hours and 25 minutes, 1.5 hours. Okay. So what we want to do is change both of these, because we're doing the difference in minutes. We need to change both of these into minutes. So 2 hours and 25 minutes. Well, 2 hours is 60 times 2, that's 120 minutes, plus 25 minutes is 145 minutes, and then 1.5 hours is 60 plus half an hour, which is 30, so 60 plus 30 is 90 minutes. So we've got to work out the difference. We'll do 145, take away 90. Now this is one of the predictions for the foundation paper. So, you know, it's a type of question, a style of question, which usually is going to be pretty straightforward, and I expect be on, you know, the early part of the paper. Okay, write these numbers in order of size. So the next thing is standard form. Write these numbers in order. These numbers in order of size. Start with the smallest. So what I want to do is work out actually all of these numbers. Now this times 10 to the power of negative 4. That negative 4 basically means divide by 10 4 times. So my decimal point is going to go from there, and I'm going to go 4 jumps essentially. When you divide by 10, it looks as though the decimal point is jumping to the left, doesn't it? So this is going to look as though the decimal point is jumping 4 places to the left. So 1, 2, 3, 4. So that is going to be 0.61. This one times by 10 twice. 1, 2, so that's going to be 6.1. And this one is 6.1 times 10 twice, so 1, 2, so 6, 1, 0, 610. So these are the numbers, and when you put them in order, you've got to write the originals. You can't write down, you know, what we've worked out there. So the smallest one is going to be this 0.61. So that's 6,100 times 10 to the negative 4. And then the next one, we're starting with the smallest number, yeah, that's right, is going to be 6.1. So that is 0.061 times 10 squared. And then we've got 61 over here, and then 610, which is 6.1 times 10 squared. Okay. Next topic is solving equations. Okay. Now this could be mixed into loads of different types of questions. It could be something straightforward like this, or they could ask you to do some other topic. Put algebra in it, and then you would be required to then solve an equation as part of your solution in that other question. So it could be like this. It could be a kind of hidden solving equations question. Okay, so what I need to do here anyway is balancing line. I need to take away 7 because basically I need to have x equals at the end. So I need to get rid of everything that's affecting the x. Everything that's happening to it in in the reverse process. So I would plug a number in for x, say 2. I do 2 add 7. So the first thing I need to undo is adding the 7. So I need to take away 7 from both sides, and that's going to leave me with x is equal to 6. And then that's my answer. Solve means work out what the letter is. So this one, again, balancing line, I want to add 5 to both sides. Because if I was to substitute in a number, I'd do 3 times 2 is 6, take away 5 would give me 1, not 12, so, you know, h isn't 2, but that explains what the order of the operations in your head, because sometimes it's not always clear just looking at it, so plugging in a number can help, and then basically do that backwards and the inverse operations. So the last thing I did was take away 5, first thing I need to do is add 5. So I end up with 3h is equal to 17, and then after that I need to divide by 3, because if you've got a number next to, like directly next to a letter, that means you're timesing them together. So divide by 3 here, and I'm going to get h is equal to 17 over 3. Now it's always better, unless it says in the question to round it, it's always better to leave it as a fraction, okay? So leave that as 17 over 3. Now what I want to do is just check that in here. So 3 times 17 divided by 3 gives me 17. 17 take away 5 is 12. So I know that's right. So you can almost always check your solutions to an algebra question by substituting back in to the original question. Okay. Next question says, here are the first 5 terms of an arithmetic sequence. Now that word is a key word because it tells you that it goes up this sequence by the same amount each time. And if I have a look, what's the difference between 2 and 7? That's 5. 5. Yeah, they're all going up by 5. Now, the fact it's an arithmetic sequence, and I've seen that one of them goes up by 5, tells me that all the rest will, but you want to just check anyway, because you might have made a mistake in subtracting your numbers. So, write down an expression in terms of n for the nth term. So we need the nth term of the sequence. Now, I know another sequence that goes up by 5s, and that's the 5 times table. 5, 10, 15, 20, 25. So that goes up in 5s as well. So, but the difference between my 5 and 2 is 3, so I need to take away 3. And I need to do that to all of my 5 times table, and then it would work. Now, in terms of the nth term for the 5 times table, well, that would be 5n, because you would do 5 times 1, 5 times 2, 5 times 3, 5 times 4. So we get 5n subtract 3, and that's the nth term for that sequence. Okay. Right, so moving on to some more questions that were on these predictions. So this is, well, this is a basically combined prediction, because it's the area and the perimeter of a rectangle, so a rectilinear shape, and also bounds. Okay, so it's, yeah, combining topics, which is what they might do on the exam as well. Now, all of these questions are from Maths Genie, so they are past paper questions as well. So this gives you an idea of the things in the format that they can ask these questions in, and what you can expect. Okay, so first thing we need to do is read the question. A rectangle has a length of 21 centimetres to the nearest centimetre. Now, as soon as I've read that, I'm going to start working things out. So the nearest centimetre. Now, if I have 21, and I'm thinking about, actually, the nearest centimetre, if I go a centimetre below, that's 20, centimetre above is 22. Now, the bounds are always halfway, because, you know, if you're less than halfway, you go down. If you're more than halfway, you go up with your rounding. So that lower bound is going to be 20.5, and that's going to be 21.5 as the upper bound. Now, we can't actually have 21.5 because that would go up if we were to round it, but anything even the slightest bit below 21.5 would be would work. So that's the upper limit, if you like. And a width, so this is the length, and then the width of 5.3 to the nearest millimetre. So that's 5.3 centimetres to the nearest millimetre. What I want to do is I want to change that to millimetres. That is 10 millimetres in a centimetre, so 53 millimetres. And then what I want to do is do the same process, so 53 in the middle. I want to go a millimetre down, a millimetre up, and then go halfway in between. So 52, 54, 52.5, 53.5. So in terms of centimetres now, what that would be, because it's probably easier to have everything, especially because we're going to work out the area in the same units. So this is the width. 52.5 would be 5.25 centimetres and 5.35 centimetres. So lower bound is 5.25 centimetres, upper bound is 5.35 centimetres, and over here for the length, lower bound is 20.5 centimetres and upper bound is 21.5 centimetres. And then we need to just work out these questions. So perimeter, well, it's a rectangle, so it's going to have 2 of the lengths and 2 of the widths added together. Now, when you're thinking about actually which limits, which bounds do I need to use, it basically depends on the operation. Now, addition and multiplication are very straightforward, because if you want the upper bound for the perimeter, if you're adding things, then if you want the upper bound, you use all upper bounds. If you want the lower bound, you use all lower bounds. Timesing is the same. If you want the upper bound, you do all upper bounds. If you want the lower bound, all lower bounds. But subtraction and division are slightly, well, they're different. They're different, and they're not as intuitive and straightforward as that. So, for instance, if you want the upper bound for subtraction, you want to have the upper bound take away the lower bound. So your biggest number take away your smallest number will give you the biggest answer. If you want the lower bound for subtraction, lower bound take away upper bound. For division, you want to, if you want the lower bound, you want to do the smallest number divided by the biggest number, because it will go in the least number of times. And for the upper bound for division, you want the upper bound divided by the lower bound. Okay? If in doubt, work out all the 4 variations for subtraction and division, and then get your 4 answers and see which one is the biggest, which one's the smallest, depending on what you want. Okay? Right, so like I said, addition, so the perimeter is going to be easy. It's going to be, we want the upper bound, so 21.5, add 21.5, add, we want 5.35, add 5.35. So do that on the calculator and we'll get the answer. 5.35, add 5.35 gives 53.7 centimetres. Now also for this question, I don't really have enough space, but it might be a good idea to actually just draw the rectangle to give you a reminder or recap, or just something else to reduce the chance of you making a mistake. Draw a diagram of the rectangle, okay? Just so you don't do something silly like only add 21.5 and 5.35 and only do 2 of the sides. Now the area, we want the lower bound, so that's easy, lower bound times lower bound. So we want 20.5 times by 5.25, and that gives us 107.625, and that is centimetres squared. Because, oh sorry, no, yes it is, yeah, I thought I had it the wrong way around. Yep, there we go. Okay, next question. Jerry and Mick share some money in the ratio 2 to 3. Mick gets £900. Work out how much money Jerry gets. The way I do this, if you've watched the videos before, if I've taught you before, you'll know, is to use basically a bar modelling method. Or boxes, as I like to call them, because you can always add more boxes on. You can't really kind of increase the length of your bar. I suppose you could, but yeah, I just prefer thinking of them as boxes. They're the same size, so I want 2 boxes and 3 boxes. Okay, so there we go. Now I need to know who's who, so that's Jerry, that's Mick, and Mick gets £900. So those 3 boxes must be £900, which means 900 split between 3 is 300. And so you write those in the boxes, and all the boxes are the same size, so they're all 300, and then Jerry gets 300 times 2, which is £600. Okay, super. If you use that bar modelling or the boxes method, it makes things more straightforward. Okay, Annie invests £9,500 for 5 years in a savings account. She gets 1.8% per annum, that means per year, compound interest. So that means basically they're going to work out the percentage off how much money she's got in this savings account at the end of each year. So you're going to increase the amount of money because you're going to be working out this percentage of a larger and larger number each year as it increases. So it compounds. The percentage is working out a percentage. Basically the percentage works out each year the percentage of the original amount plus all the percentages added on from the previous years, which is why it's compounding. Okay, so £9,500, the original amount, times by, it says how much money does Annie have at the end of 5 years. Now it doesn't ask about the interest, it asks about the total. So 9,500 and then times by, we want that as a multiplier. So that's going to be 100, add 1.8, 101.8, and then change that to a decimal. So 1.018, that's the percentage multiplier. So this will give me an increase of 1.8% straight away. Now I want to do that for 5 years, and it happens each year, so I want to do that 5 times, so power of 5. Okay, 9,500 times 1.018 to the power of 5, and we get 10,386.34. You want 2 decimal places because it's money. And that's it. That's all you need to do for that question. Next one is about, what's it? It's a proof, because it says proof, algebraically, basically showing that a reoccurring decimal is a certain fraction. Okay, this is basically very procedural and straightforward. You just need to know the process. Some of these can be a bit tricky depending on which part of the decimal is reoccurring, but you know, in most scenarios, and it's not too difficult, that bit. So start off by saying x is equal to 0.23333. Now I wouldn't write x is equal to 0.23 with a dot above it, because it's easier to think about conceptually what's going on if you're writing the repeating part out and you can then see that that's repeating. Otherwise you might get confused with the fact that is it 2 and 3 repeating, or is it just the 3 repeating? Now the bit that repeats is the bit with either the single dot above it or the part between 2 dots above it. So if you had something like 0.345 and the dot was above the 3 and the 5, then that means, that it goes 0.345, 345, 345, ... forever. Okay? So, x is equal to 0.2, 3 reoccurring. What I need to do is get some multiple of this with just the reoccurring part on the right hand side of my decimal. So, times it by 10, I get 10x is equal to 2.333 reoccurring. Okay, now I need another multiple of this with the same recurring part. So I want to go with, or times it by 10 again, 100x is going to give me 23.333 reoccurring, because I'm just moving the decimal point, but the 3 is still going to carry on. Take these two away from each other. So 100x, take away 10x is 90x, and that will be 23.3 reoccurring, take away 2.3 reoccurring. 23 take away 2 is 21, and the 0.3s will cancel each other out. So I've got 90x is equal to 21. So divide by 90 on both sides, and I get x is equal to 21 over 90. Now you've got to check at the end if you can simplify it. Now I know 3 goes into both of those. So 21 divided by 3 is 7, 90 divided by 3 is 30, and that's what I needed to prove anyway, so I know that's where I should have ended up and what it should simplify to. Okay, next question. It's all you need to do for that question. You know, you don't need to write any words, you just need to do it with algebra. Kind of given away by the fact it says algebraically in the question. Okay, so next question is on volume of 3D shapes. So if I just have a quick look and just check which one that's going to come up on, so that is volume of 3D shapes, I believe is on AQA that it comes up on. Yes, it is. The higher AQA is the prediction for volume of 3D shapes. So essentially, there are, of course, lots of 3D shapes. I've gone for a prism because that is, I think, well, the method for working out the volume of a prism can be basically applied to many different prisms and cylinders. So it was, I think, the best shape to go through now. There are others, so spheres, cones, surface area of cylinders, or, you know, that's not what's predicted, it's the volume. But yeah, prisms are, the method is applicable to all of the prisms, basically. All you've got to know is how to work out the area of your 2D shapes, and then just times by the depth. That's it. So it's the area of your cross-section, which is the shape that is the same all the way throughout. So if I was to cut this 3D shape down here, I would still see this kind of L shape throughout the shape. So I need to work out the area of that and then times it by 12, the depth. Okay, so I'm going to split this L shape up into 2 times by, well, the full height's 3 and the height of that's 1, so that's got to be a height of 2. 2 times 2 is 4. And then I've got 1 times 4, which is 4. 4 add 4 is 8. So the area of the cross section is equal to 8 centimetres squared. So the volume is equal to 8 times by 12. Okay, 8 times by 12 is going to give me 96 centimetres cubed. Okay, so volume of a prism, area of the cross section times by the depth, and that works with cylinders as well, although technically cylinders aren't a prism because they don't have, well, they have a curved face basically, and you have to have flat faces for prisms. Okay, the next thing is SOHCAHTOA, or trigonometry. Work out the value of x. So we've got side here, now that's opposite my angle. I've then got the hypotenuse, which is here, but I don't want the hypotenuse and I don't have it, and then adjacent here. So I've got opposite and adjacent. Now you might do this in different ways. You might remember the triangles. I remember just SOHCAHTOA, so just writing that down. Now I need, well, I've got need or have opposite and adjacent, so that is tan, so that's this one, so that means tan 42 is equal to opposite, so x over 11. Okay, then what I need to do to get the x is times both sides by 11, and I get 11 times by tan 42 is equal to x, and then I have to plug this into my calculator, so that means that x is equal to 11 times by tan 42. Make sure your calculator has the d at the top, that means it's in degrees. If it has the r at the top, it means it's in something called radians, then it will work out sine, cos and tan wrong. You'll get the wrong answers, okay, for anything you work out with sine, cos and tan, so make sure that isn't the case when you go into the exam. So 9.9, it doesn't again give us something to round it to, so I'll just round it to 1 decimal place. 9.9 centimetres. Now when you have worked that out, just look at the diagram and think, well, that's 11, is it plausible that that's 9? It's plausible. The diagram obviously isn't drawn accurately if that's the case, but it is plausible if one side is 11, the other is going to be 9, you'll have an angle of 42. Because if that's 42 and that's a right angle, and this angle over here is going to have to be 48. So these sides must be very close to being the same length, because your angles here are very close, which means you're very close to having an isosceles triangle. Okay, so 9.9 is relatively close to 11. So yeah, that sounds about right. Okay, and then the next one is solving an algebraic fractions question. Now algebraic fractions is something that I would recommend if you're aiming for, 7, 8 or 9, just making sure that you've practiced algebraic fractions, because they can be a bit tricky. I picked a relatively tricky one here on algebraic fractions, because it's not only algebraic fractions, but you also have to solve the equation and find out what that x value is. Okay, so the first thing with algebraic fractions is just remember the rules of fractions and what you can do and what you can't do. Okay, so here it wants me to add them. So in order to do that, they have to have a common denominator. We have to have the same thing on the bottom of the fraction. Now if it's something a bit complicated like this, 3x minus 2 and x plus 1, just times the two things together. So on the left hand side I'm going to times top and bottom by x plus 1, and on the right hand side I'm going to times top and bottom by 3x minus 2, and that will make sure that on the denominators I have, well, the same thing, x plus 1 and 3x minus 2. So times top and bottom here by x plus 1. So on the top I'm going to get 8x plus 1 is over x plus 1 brackets 3x minus 2 plus times this one by 3x minus 2 top and bottom. I'm going to get 6 lots of 3x minus 2 all over x plus 1, 3x minus 2, and that's equal to 2. And then what I want to do is, well, then I can write that as one fraction, and actually what would probably be easier is multiply up by that denominator. So bring up x plus 1, 3x minus 2 to the other side, times both sides basically by x plus 1, 3x minus 2. Okay, so if I do that, times by x plus 1 and 3x minus 2 on both sides of my equals, I will get this. 8 lots of x plus 1 plus 6 lots of 3x minus 2 is equal to 2 lots of x plus 1. I'm drawing brackets all over the place here. Let me start that again. 2 lots of x plus 1, 3x minus 2. Okay, so what we then need to do is expand this, and on the right hand side I'm going to end up with a quadratic. Okay, so I'm thinking now, I know my quadratic formula, that's fine, I can solve it, even if I can't factorise it. And then this part here, I need to expand that and then basically get everything onto one side so it's equal to 0, so then I can solve it. So, let's start expanding things. So I get 8x plus 8 plus 18x minus 12 is equal to 2 lots. I'm just going to expand those two brackets. 3x squared plus 3x minus 2x is going to be plus x minus 2. Okay. So on this side, I'm going to collect my like terms. 8x add 18x is 26x plus, well actually not plus, it's going to be minus, so we get plus 8 minus 12, that's going to be minus 4, is equal to 2 lots of this, so 6x squared plus 2x minus 4. Now I'm going to have to go over here now, because I'm running out of space. Now what I'm going to do is I'm going to take away from both sides 26x. So I'm going to end up with 2x, take away 26x. So I want to end up with 0 on the left hand side. I'm trying to say too many things at the same time and my brain's not quite working quick enough. So on the left hand side 0, on the right hand side 6x squared, because I'm not taking away or adding any x squared terms. I'm taking away 26x from 2x, so that'll give me minus 24x, and then I'm going to add 4 to both sides. Well, that's going to cancel out this minus 4 actually, so that's going to make my life a bit easier here. So, right, that's fine. Now I've just end up with this. Now, because I don't have that constant term at the end, I know I can factorise out an x. I can also factorise out or divide by 6. So what I'm going to do, I'm going to divide by 6 on both sides, because 0 divided by 6 is still 0. So 0 is equal to x squared minus 24x is going to give me, divided by 6 is 4x. Factorise it, I get 0 is equal to x, brackets x minus 4. So x is equal to 0 or x is equal to positive 4. They're my solutions. Now at this point I'm thinking I've done quite a bit of work here. You know, there's a lot of multiplying out, a lot of things are going on. So I want to check my answer at the end. So I'm going to get my calculator. I'm going to basically substitute in here 0 and 4 in two separate calculations, and they should both give me 2. Okay, so 8 over 3 times 0 minus 2 plus 6 over 0 plus 1 is equal to 2. Good, that works, which means the other one almost certainly works as well, but I'm still going to check it just in case. Okay, yes, super. So that's how you know you've got it right during the test. Also, that's also useful because that means you don't need to spend any more time worrying about it. That's that question ticked off. Forget about it. Okay. Right, moving on. These are the last questions I've got, and these are some trickier ones. So I've got at the top here a question on working out the size of angle B, C, D. So that is going to be using some trigonometry, I expect, because we're working out this angle, and we've got right angles here. Yes, it's got to be trigonometry. And then we've got some differentiation here, which is only applicable to IGCSE. But having said that, if you're interested in going on to A-level maths afterwards, after you've done your GCSEs, then differentiation is on there, and it is relatively a straightforward topic in most scenarios. Well, it will be on the IGCSE in comparison to A-level. And then another ratio question here, but one that is trickier, and one that I would, if you are putting topics or types of questions into, different grades, this would be, I would expect a grade 9 student to be able to answer this. I would say this is generally a grade 9 student, maybe top of the grade 8 question, because it is a bit tricky, in terms of actually thinking about what you've got to do. Having said that, once you've seen one of these types of questions, it is, I think, pretty straightforward, in my opinion. Okay, right, so let's go through this one. Work out the size of angle B, C, D. So we need to get to this angle. Now we've got one side here opposite. If I can get another side, I can then use trig to work out the angle. Now I'll just write down TOA, just so I've got that. Now I do have here an angle and a side, so I can use those two pieces of information to work out another one of my sides. So I can work out this bottom side, take that away from 22 will give me this side, then I can do my trig to work out the angle. So that's what I need to do there. Right, so this might get a bit confusing with labelling, because obviously I've got two triangles and they share a side, so yes, be careful with that. So this angle, I've got, this is the opposite, and then this is going to be the adjacent, because that's the hypotenuse, and I don't want that, and I don't have it, so just forget about the hypotenuse. Now, from there, what I want to do, I've got O and A, so that's tan, so tan 37 is equal to 9 over the adjacent, which I'm going to call, well, is AD. Okay, now what I need to do is then rearrange this, so times by AD, and I get AD times tan 37 is equal to 9, and then divide both sides by tan 37, so AD is equal to 9 over tan 37. Okay, now that's going to be not a very nice number, it's going to be a decimal, which means I probably want to leave it like that, and then just call this length 22 minus tan 9 over tan 37, because otherwise I don't want to, well, I could get a rounding error. I don't want to get a rounding error, which is why until you get to the end, leave all your calculations in an exact form, so something like a fraction, or a trig function like that. So 11.94 is what I get, and it's a decimal, not a very nice decimal. The other thing you can do, if you don't feel comfortable leaving things in an exact form, like 9 over tan 37, is write down all the, what I would recommend is write down all the decimals on your calculator, because then the discrepancy will be so far down in terms of the decimals that it won't affect your answer at the end, because you'll round it like to one decimal place in this question. So, and to be honest, when I was younger, that's what I used to do, because yeah, I didn't used to leave an exact form. I just thought I'd write down all the decimals, then that's fine, it will be fine. Right, so that's 11.94 dot dot dot. So this bit, so from C to D, is going to be 22 minus that. So that's going to give me actually 22 minus answer 10.05659. 10.05659,661. Okay, so I've written down all the decimals, so it shouldn't go wrong. I won't get a rounding error at the end. Now, looking at this angle, I have got the opposite, so actually the labelling hasn't changed at all, so that's pretty nice. But obviously with other similar questions where you've got interconnected or connected triangles, just be careful of that labelling. Okay, and this is the adjacent again. So again, it's going to be using tan. So tan of, I'm going to call this x. So tan of x is going to be equal to opposite over adjacent, so 9 over this number, so 10.05 dot dot dot. And then to get x, I need to do inverse tan, so tan minus 1 of 9 over 10.05 dot dot dot. What I'm going to do, I put dot 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 there because I'm just going to use my answer button on my calculator to have that. So I'm going to do shift tan minus 1, and then fraction 9 over answer button, and then close bracket equals, and we get 41.8 to 1 decimal place. Okay, super. That's that question finished. The next one is this differentiation one. So first thing we need to do with differentiation is make sure that we get everything as powers rather than something like 2 over x like that, or 2 divided by x. Okay, so, and we need to find the coordinates of this stationary point. So it's got a stationary point, and I've chosen not only a differentiation question here, but one where we've got to find a stationary point. So that means that's when dy by dx is equal to 0. So you need to write that down for this type of question. Dy by dx equals 0 at a stationary point. Now, I haven't taught GCSE in previous years. I haven't taught it really, or before actually. So I know at A level they want you to state this. So I would expect they may want you to state that as well, which is why I've said need to write that down. Okay, there's literally a mark at A level just for writing that down. If you do nothing else, that's 1 mark. So then what we need to do, dy by dx is when this is differentiated. So dy by dx, so differentiate this. Now first thing I want to do, write it as 8x squared plus 2 to the power, 2 times x to the power of minus 1. Now differentiate this, so bring the power down, so 8 times 2 is 16, x, take 1 away from the power, so x to the power 1. And then minus, because negative 1 times by 2 is minus 2, or subtract 2, x to the negative 2. So what that gives us is 16x minus 2, and that's x to the negative 2, so that's divided by x squared. Okay, now we want that equal to 0 because that's when we'll have a stationary point, and we want the coordinates of that stationary point. Okay, so we want an x and a y. So we want to do 16x minus 2 over x squared is equal to 0. Put the 2 over x squared on the right hand side, so that will then become positive, or add 2 over x squared to both sides. You get 16x is equal to 2 over x squared, times both sides by x squared. We're going to get 16x cubed is equal to 2. Divide by 2 on both sides. So then we're going to get 8x cubed is equal to 1. And then what we need to do is divide by 8 and cube root it. So I'm just going to go over here. Divide by 8 on both sides, we get x cubed is equal to 1 over 8. Then we need to cube root. Okay, so we're going to get, well, cube root of 1 is 1, cube root of 8 is 2. So we get x is equal to a half. When x is equal to a half, y is going to be equal to 8 times a half squared plus 2 over a half. So y is equal to, plug that into your calculator, 8 times a half squared plus 2 over a half, which is 6. So the coordinates of that stationary point, that turning point, are a half and 6. Okay, that's the answer. Right, now the last question, 5 minus 3x and 9 minus x is equal to 3x plus 7 to 4 minus x. Find the possible values of x. Now, hopefully there's enough room on the paper for this. What we need to do is basically some multiple of this has got to be equal to some multiple of this, and some multiple of this has got to be equal to some multiple of this. Okay? And that should then allow us to work this out. So, if we just think of some other variables, usually, well, not, I'm going to go with m and n. I think in this scenario where you've already used x and, well, not y, but y would go with x. You need to have a pair, don't we? So m and n makes sense. So m lots of 5 minus 3x is equal to n lots of 3x plus 7. Okay, so that means this bit, some multiple of that has to be equal to some multiple of this, and this could be, you know, it could be a half, which could mean you're dividing by something as well. Right, so that means you get 5m minus 3mx is equal to 3nx plus 7n. Okay, now what we want to do here is compare the numerical parts of each of these and also the x parts, because they're going to have to be the same. Right, and then we've also got the other bit, which is 9 minus x times by m is equal to 4 minus x times by n. Okay. What we're looking for really is a way we can write m in terms of n and then substitute into the other one and work it out that way. So we get that we have to have 5m is going to have to be equal to 7, actually no, I'm going to rearrange this, so I'm going to put this on the other side, so I've got all my x terms together and all my number terms on the other side, and see if that's going to help me first of all. So I get add 3mx plus 3nx, take away my 7n, so 5m minus 7n. Okay, so those two things have got to be equal to each other. I can factorise out here my 3x is equal, sorry, 3x brackets m plus n, and then I've also got, well, I can't factorise anything out of there, but what I could do is get something for x and in terms of m's and n's, and then solve that later on. So that's equal to 5m minus 7n. If I then divide, so I get x is equal to 5m minus 7n over 3m plus n in brackets. I've got something there. Okay, now I'm not sure if that way is going to help me. I don't think it will. I think what we need to do actually is compare these coefficients back here again and actually say, well, 7n has to be equal to 5m and minus 3m has to be equal to 3n. Would that work? Right, okay, need some more paper regardless, so I'll grab some more paper. Okay. Right, let me just fold this so you can still see it. So just one. From there down, actually I can write on the back of this piece of paper. Okay, so I could end up with something like that, and then I'm thinking, well, is this going to help me? Now let's also, while I'm doing this, look at the other one. So m lots of 9 minus x is equal to n lots of 4 minus x. Okay, so I'm going to get 9m minus mx is equal to 4n minus 4x. No, sorry, nx. Okay. So, again, if I do a similar thing, 9m minus 4m, take that to the other side, is equal to mx minus nx. We get, factorise out the x, m minus n, 9m minus 4, that should have been n, 4n, and then x is equal to 9m minus 4n over m minus n. So I've now got two things for x which have to be equal to each other. And I could set these equal to each other and try and solve them simultaneously with these two equations. So if I have 5m minus 7n all over 3m plus n is equal to, excuse me, the problem is, and why this isn't going to work, why I'm going to find difficulty doing this, and if you tried this way, how I know this isn't going to work, I've got one equation here and I've got two variables, and so there isn't a way that I can work it out with two variables. Now I had initially two equations, but then I've got three variables. I've got x, I've got m, I've got n. So this is why the method of actually comparing it's usually called comparing coefficients, basically, because you're comparing the numbers or the things out the front of your x terms. So if I look here, or if I go back, this is going to basically give me a problem. So if I go back here, if I say that 5m has to be equal to 3n, okay, 5m has to be equal to 3n, then, oh sorry, not 3n, excuse me. So you want, if I do it in a different colour, this is going to be a number term, and then the other number term is 7n. So 5m is equal to 7n, okay. Now if I divide this by 7, I've got 5/7 of m is equal to n. Now once I've got that, I've got something else I can use to plug in to one of these other equations. I've got a value, well, I've got what m is in terms of n. Now if I also look at, so let me use another colour, the x part, so I've got minus 3m and I've got 3n. Okay, so that tells me minus 3m, that's equal to 3n, then I'm going to get divided by 3, I'm going to get minus m is equal to n. Okay, so I've got some different things here which is going to make things a bit tricky. So these two things also are different, aren't they? So this method may not work either. Okay, what else can we do? Now with ratio questions there is always some trial and error you can do, but that's not the method I want to use. So, hi Max, just seeing you in the chat. Good to see you. Find the possible values of x. Now it's got to be to do with the multiples, isn't it? It has to be to do with the multiples, but this method again, I'm either doing it slightly wrong or it's going to lead us to an error in the way we're doing it. Now, if we say that, now we want the possible values of x, so what could x be to make this work? So, because the reason I've done multiples here is because they can simplify to each other. So which ones could simplify to give you, another one? Do I need m and n? I'm not sure that I do, because a multiple of one of them has to give the other one. So I think the where I'm going slightly wrong with this, I'm doing multiples of both. If you do multiples of one thing, then you have one less variable, and a multiple of this has to be equal to this, even if it's like a half, a third, even if you have to divide to simplify to get to it. Right, so that's where I'm going wrong. I'm doing two variables extra, where actually I just need to do one. So what I'll do is, I will use this other paper. So we only need to do one multiple, don't we? So let's go with m lots of 5 minus 3x is equal to 3x plus 7. Okay, so 5m and then minus 3mx is equal to 3x plus 7. Okay, and then we've also got m lots of 9 minus x, so the same multiple, because it has to be the same multiple, has to give us 4 minus x. So 9m, minus mx is equal to 4 minus x. Okay, so from there, 5m minus 3mx is equal to 3x minus 7, sorry, plus 7. So what that means is that if we can get something which is just in terms of x's and solve for the m, because we've only got one variable, that should work, okay? So what I want to do, or what I could have done actually at the start, is this bit here, just divided by that, so that would give me m is equal to 3x plus 7 divided by 5 minus 3x. And then this one will give me m is equal to 4 minus x over 9 minus x. So we're going to get basically so I'm going to put these two things equal to each other, so 3x plus 7 over 5 minus 3x is equal to 4 minus x over 9 minus x. And then I'm going to cross multiply, so I'm going to bring that one up here, bring this one up here, so 3x plus 7 times by 9 minus x is equal to 4 minus x times by 5 minus 3x. And then I'm going to multiply these out. I'm going to get a quadratic equation and then I'm going to solve it, and that will give me my values of x. So 3x times minus x is minus 3x squared. 3x times 9 is going to give me 27x. 7 times 9 is going to give me 63. 7 times minus x is minus 7x. That's equal to 4 times 5, which is 20, 4 times minus 3x, which is minus 12x, minus x times 5, which is minus 5x, minus x times minus 3x is going to be positive 3x squared. Now we need to collect all our like terms, so I've got minus 3x squared plus 20x plus 63 is equal to 20 minus 17x plus 3x squared. Now we need to get everything onto one side, so I'm going to add the 3x squared, take away 20x, take away 63. So I'm going to get 0 is equal to 3x squared, add 3x squared is 6x squared. Take away 20x from 17x, I'm going to get minus 37x, and then plus 63, but take that away, so I'm going to end up with minus 43. Okay, now, then use quadratic formula, so I'm going to do minus b, so fraction button, minus b, so plus 37, I'm going to check this at the end because these numbers seem a bit strange, but we'll see, plus or minus the square root of b squared, so minus 37, put that in brackets, squared, minus 4 times a times by c, which is minus 43, all divided by 2a, so divided by 12. So, I'll just do 2 times 6. Do that, and I get 43 over 6. So x is equal to 43 over 6, or x is equal to minus 1. Okay, now on the question, it says find the possible values of x. Now minus 1 is a pretty straightforward value, so that's fine. The other one, 43 over 6. Now what this does tell me is actually I could factorise this, okay, which suggests that this probably is right, because they'll want to give you something you can factorise usually. If I got some random decimals, then I would have been less convinced, but either way I can just try the numbers. So if I try in here 5 minus 3 times negative 1, so do that on the calculator. 5 minus 3 times negative 1, I get 8, so it could be 8, 2, and then 9 minus negative 1 is 10, is equal to, and then 3 times negative 1 plus 7, 4, and then this would have to be 5. So 4 minus minus 1 is 5, good. They are the same, because that will simplify to this. If I try it with the other value, so 5 minus 3 times 43 over 6, I get minus 33 over 2, and then I need 9 minus 43 over 6 is 11 over 6. Is that equal to, it should be because the first one was right, 3 times 43 over 6 plus 7, 57 over 2, 2 and then 4 minus 43 over 6, minus 19 over 6. Okay, and what multiple is this of this? Well, if I do, as long as the multiple is the same, if I do 57 over 2 divided by negative 33 over 2, I'm going to get negative 19 over 11, so that's basically my scale factor. So if I did negative 33 over 2 times that, I'm going to get this one. Yes, so this times by negative 19 over 11 gives me that, so 11 over 6 times by the same scale factor, negative 19 over 11 gives me negative 19 over 6, so it works. Yeah, that is a multiple as well. Super, so there are my two values. X is negative 1, X is 43 over 6. The only issue I had at the start was basically I gave it too many variables, too many multiples of things, which just made my life too difficult, and actually you couldn't do the question that way. Okay, right, so I hope that was useful, and there's lots of ideas there about what to do with your revision. Okay, if it has been useful, please like the video, because that lets me know it's useful, and then I'll make sure I do one of these videos again to help you with your revision. And I would recommend using the resources in the links that I put in the description, the resources that I've gone through, the predictions of what's going to be in these papers. Okay, yeah, and if you want me to necessarily go through another topic or a specific topic next week, that's fine. Please put it in the chat and I'll make sure to go through that in next week's session. And of course, if you do want to support the channel by buy me a coffee, again, that's the QR code's on the screen or the link in the description. Okay, right. Have a good week, everybody. Good luck with all your exams, and yes, I will see you next week, same time, same place. Okay, bye bye.